Hello, everybody, and welcome to this presentation. You've probably seen this disclaimer already. Everything I say is most likely true, and it was true to the best of my knowledge, but things change, so please keep that in mind. And we'll move on now and begin the presentation. So welcome to the Hybrid Data Conference. This is the Edge to Cloud without ETL mobile and IoT data management with Actian Zen presentation. I got through that. My name is Tom Bates, and I'm a principal software engineer with Zen Engineering and of course with Actian. Questions during this presentation. So if you have any questions, please enter them in the chat as you think of them. A moderator can respond. There's also an Ask the Experts track where questions on any topic can be asked, hopefully related to Zen or Actian. And if you have any questions that you think of later or you have follow-up questions, please email desmond.tan@actian.com and you guys can connect after the conference, excuse me. All right, so what are we covering today? We're covering how Zen eliminates ETL and improves security. And then there's a few demonstrations at the end that we'll cover as time permits. So first, what do I mean by ETL? Let's take a look. In the environment, in your environment, you probably have more than one sort of data you deal with. Perhaps transactional, JSON, or just simple text, video, images, audio, multimedia, and then the data types are practically endless, right? So whatever it is you're dealing with. In addition, you also have multiple operating systems that you're dealing with: Windows, Linux, Mac OS, smartphones, right? iOS and Android tablets, small little devices running Raspbian, whatever it may be. And then in addition to that, you've got multiple architectures, and I've put the two most popular that I know of anyway here, and that's Intel and ARM. And then, as if that weren't all enough, you've probably dealing with multiple databases. So perhaps you're running SQLite on smartphones, MySQL on Linux-based devices, SQL Server on Windows boxes, Couchbase for NoSQL needs, MongoDB for document stores, and InfluxDB for time series if you have that sort of need. And additionally, flat files are still fairly commonly used. So because of all that, you're probably extracting your data, transforming that data so it's compatible with the next database, and then loading that transform data into that next database. That's a lot of work to be done. And that's why I've put a little factory icon in the middle of this diagram. Also, if you're supporting multiple databases, your staff must gain and maintain proficiency in those databases and their APIs. Gaining and maintaining that proficiency is difficult. That's why I've put a plate spinner in the middle of this diagram. Well, with Actian Zen, that changes. The ETL, as I've defined it, is no longer necessary. So you may still be moving data from one place to another, but you're not required to transform that data. So no transformation of data means there's a lot less work to be done, excuse me. That's why there's an efficient hybrid in the middle of this diagram. And if you'll excuse the bad joke, this is the Hybrid Data Conference. Also with Actian Zen, you're only supporting one database. That means your staff only needs to be proficient in one database and its APIs. Gaining and maintaining that proficiency is much easier. Those staff, developers, and support personnel are now very relaxed and collected. I'd even say they're very Zen. That concludes the eliminate ETL part of this presentation. Once again, if you have any questions, please feel free to enter them in the chat. Now we're going to move on to how Zen will help improve security. As I covered previously, ETL requires extracting data from one database, transforming that data into so that it's compatible with the next database, and then loading that transformed data into the next database. For encrypted data to be transformed, it has to be decrypted, transformed, and then re-encrypted. This means that the data is not encrypted for a period of time, and during this time, the data could be stolen. With Actian Zen, there's no required transformation of data. So no transformation means no decrypted data, and that means that your data stays safely locked. And that concludes the improved security part of the demonstration. Once again, please feel free to ask any questions you might have. Now we're going to move on to the demonstrations. So this is the hardware and software for the facial recognition demonstration. Just to go over the components quickly, the NVIDIA Jetson is a small computer that can run AI workloads, neural networks, and process data from sensors simultaneously. It runs Linux for ARM 64-bit. The Apache HTTP server is just that. It's an HTTP server. PyTorch is a machine learning library. TensorFlow is a platform for machine learning. And NVIDIA Sensor RT is an SDK for deep learning inference. And of course, Actian Zen, which is a highly reliable, small footprint, low maintenance, high performance database management system. And this is the hierarchy of this demonstration. Notice that Python and PHP are being used by their Btrieve clients, and the Btrieve clients are available for multiple languages. These include C, C++, C#, JavaScript, and Perl. And now we're going to switch over to the facial recognition demonstration. All right, so now I need to share the Jetson. And here what we're seeing is I'm logged into the Jetson because I need to start the camera. So I'll be starting the camera now. It takes a few seconds to start up. Okay, the camera has started up. Now I will switch us over to the dashboard that we'll be using to talk with the Jetson. Okay, so here's the dashboard. So let me unshutter the camera. And there I am. So to describe what's going on here and how it relates to Zen, the top left box here is a streaming, is the image is streaming from the camera, a few a second. And then the one on the right here is the latest positive image. So it's seeing my face, so it's reporting that, it's writing to the positive images file. And then down here on the left is the contents of the images file, sorted by date. And you can see that the images as they stream, they're coming in here. And then we'll jump over here to the positive images. And that's the same thing for the images where a face has been recognized. So you can see that's streaming. So what I'm going to do is I'm going to cover my face here so it no longer recognizes me. And you can see that the images table is still streaming along, and with images coming in, but there's no more positive images. And so this is all done through the recognition in the camera script that I'm running. And once again, they both correspond to a Zen table or a Zen file. I'll unobscure my face here. Now, what's being stored in these tables exactly is some JSON information and the blob or the image itself. And so we'll take a look at the JSON real quick for the images table. And you can see in here some interesting things. They're being stored as JPEGs. There's a thumbnail in here, which is kind of neat because we've got an image or a small blob, if you will, inside the JSON. That's perfectly legitimate to do. If I pop out here, close this guy, we can also reference an image from back in time, right? Because they're being stored in the images table. And it's also true for the positive images. So let me obscure myself again. And then I want to go back in time and say, when's the last time this guy was here? And that's who he is, right? So I will bring up the JSON one more time just to show you that the detection length, for example, is one of the things that we're storing, and that's how many faces he thinks he saw in the image, and that'll come up later in the demo. So just put that away in a corner of your brain, and I'll refer to it later. What else we have out here is the networks that are being used for the inference. So we were using FaceNet. If we wanted to recognize airplanes or dogs, we could do that. And if we look at the JSON for that as well, you can see it's a completely different set of information, obviously, than for the images. And that's one of the great things about the database supporting JSON, is because we can have these different, easily support these different data types without having to worry about columns. You know, later on, let's say we wanted to add another column to the networks table. Well, we don't have to rebuild it. We just add some JSON. And let me pause this here. One of the things I want to show is this statuses table. Now, this status table is a Zen table as well. And the camera script, as he's running, he maintains and updates some statistics here, the width and height of the camera image, for example. But what I want to show you here is he also keeps track of processing time. So he says that last image he worked on took 108 milliseconds, excuse me, to process. So that includes grabbing the blob, creating the blob, capturing the image, rendering it, analyze, detecting on it. The thing I want to point out here is the store, and that's him writing to the Zen database, and that took 21 milliseconds. Now, as a percentage of the total time, that's a fairly small number. It took longer just to create the blob from the image. I also want to show stress. That's the word. I want to stress that we're storing two images, right? The latest image and the positive image at that time, and then also this web server, the Apache web server, is retrieving two images from that database. Not to mention the updates of the networks, the reading of the networks table, and the status table, the reading and writing of the status table. So Zen does not. People worry about databases introducing a lot of overhead. I think this shows pretty well that the database is not the overhead here. It's the image recognition. So that concludes the Jetson demo. So let's return to our presentation and move on. So the next demonstration is a no ETL demonstration. And what I want to stress here is that we're going to move data from the Jetson to an AWS instance that we have out in the cloud, and that this Jetson is running Ubuntu Linux for ARM64, and the AWS is running Windows Server 2016 for Intel 64-bit. So we've got a different OS and a different CPU architecture, and we're not going to have to do any sort of ETL to make that work. So let me switch over to that. So we're going to go back to the Jetson. We're going to stop this camera. And now we're going to transfer the file that we have here on the Jetson, the Zen file, to the AWS instance, if I can remember my password. Okay, so there we go. So images is the name of the Zen file that we were storing all the images in. And so I've placed that on my laptop. You may have noticed it was my laptop and not the AWS server, but I'm just simply going to stage it from one to the other. Let me go now to the AWS instance. And I'm accessing this through RDP. So what I do is I have my laptop available to this instance via RDP's ability to do that. So we're going to grab that file. There we go. We're going to move it on to this AWS instance. While this is copying, I just want to say that this is very manual, obviously, right? I'm actually copying the file myself. I'm doing this to show that there's been no massaging of the data or translation of the data at all. This file is exactly as it existed on the Jetson board when it's on the AWS instance. So there's been no transformation of the data at all. Once this is done copying, what we're going to do is we're going to look at it through another dashboard that's running on that's been coded up for the AWS instance, and look at the data and make sure that everything has transferred correctly. Okay, so we've got that up. So now I need to go to the dashboard that we're going to use to talk to the AWS instance. And there we are. I need to point this particular web page at the file. And there we go. So it looks different on this dashboard because this dashboard is a different set of PHP scripts, right? It shows the data differently. But if we look at it, the data is absolutely there. So there's the JSON that's associated. And then there's me again. So there we took a file without doing anything into it. The file, if the file was encrypted, then we would have never had to decrypt it. The data in here would have never been exposed, even though it was transferred through my laptop, right, onto the AWS instance. So that concludes the no ETL demonstration, and we'll move on to the next one. Once again, if you have any questions, please post them in the chat room. Okay, so this one we're going to go back to that AWS instance, but we're going to look at another set of data and talk about the sort of things you can do with Zen with that data. We're using a different software stack. We're using Microsoft Internet Information Services, which is IIS. That's how it's known. And I just want to say again that we're using Actian Zen, which is still a highly reliable, low maintenance, small footprint, high performance database management system. So let me now switch over to that dashboard. Go back to the top. So we've got a few demos out here. The first one we'll do is the document store demo. So this is a different set of data. We're not using just pictures of me. And I just want to stress a few things while we're here. One thing people worry about storing large things in large video files, for example, in a blob or in a database is performance. So we've got a video out here, pretty good resolution. and we're just going to stream it. And here we're streaming it directly out of the database, and you can see how quickly that started. I can jump around. There's really no issue at all as far as getting the streaming the movie. So I don't believe performance out of Zen is in any way a limitation. Another thing that we can do is we can store different types, obviously. So let's do something a little more business oriented. So here's a PDF. So if you're supporting your Salesforce, for example, they can have access to their PDFs. So anybody want to buy an elevator or parts for an elevator? And then lastly, many of these documents have very little JSON, very little metadata go with them, right? For example, this is just a file name and the type. But some documents have quite a bit and lend themselves very well to this JSON setup. So here's a JPEG. JPEGs have a lot of metadata in them. And so here we can look at quite a large amount of data has been stored in this JSON string, including a thumbnail that's actually pretty large. All right, that's it for the document store one. Now let's go to the documents one. Now this is the same file as we were just looking at. Before I go on though, I want to stress how easy it is for this to work. Now this is a different file than the one we just looked at, but the exact same code underneath, and that's simply because btrieve supports these URIs. So with a URI, all you have to do is set your server name, the location, and the name of the file. And it's that easy to change around. Okay, so we've been showing the documents. Now, Zen doesn't just support storing and retrieving JSON. It also supports querying on that JSON. So here's an open curly brace, close curly brace query. And that's how you get them all. That's like a select star in SQL if you're familiar with SQL. However, if I was just looking for that PDF, I can put that in the query box here. And we just get the PDF. If we want to do something a little fancier, as an example, we can do something like this. Now I want to stress that the querying is all occurring down in the Zen database engine. The query is sent down there, the database engine runs through the documents, parsing JSON, applying the query, and getting the answer. That's not done up by us, by the client. Okay, the next query is a file access query. So I've been talking a lot about JSON, but Zen also supports more typical, more traditional columns, right? So this table is a student table from a theoretical college, and it's got several columns in it: student ID, GPA, transfer credits, so on and so forth. And it's also can be sorted by two of these columns because we have indexes set up on them, just like any fully functional database. So I'm going to run a query here, and here's the student IDs that satisfy the query. And if we go back, I just want to show here that if we turn on some tracing, we can see that this is actually a very, very simple thing to do. We instantiate a client and a file for btrieve. We open that file via the client. We specify we want to use index 1, which is student ID, and we retrieve records several times until we get into file or records, no more records found, and then we print out the results, and then we close the file. Next, we're going to look at file information. So this is just to give you an idea of the sort of functionality that's available via Zen. Anything you would expect, I believe. Here's the indexes that I talked about. Excuse me. And also we have, do you have page compression? Do you have record compression? Are there locks? Are there transactions occurring? All the sort of things you would expect. Next is a kind of a silly program, and there's a theoretical machine that doesn't do squares and square roots. So we decide instead of calculating those all the times, we're going to create a table and do a lookup. So you can type in anything you want here. Well, not anything, but you can type in the numbers that are in the table and you'll get an answer. The reason I'm showing you this is because I want to look at the source code real quick. So here's the entire program that I'm scrolling through. And much of this program is actually the overhead because this is a PHP script running in a web server. The things I want to stress here is that we create the file. Every time you push that button to submit the number, we create the file, we open the file, we populate the file, we put an index on it, we retrieve the records you requested, and here's closing the file, and then if you wanted it deleted, we delete the file. So this is the basic structure that anybody does, right? And most times you wouldn't be creating and deleting and populating the file constantly, right? You would just be retrieving records and updating records. So it's a very, very simple API to use. And that concludes the AWS demonstration. So let me return us to the slides. And that also concludes this presentation. I want to thank you for attending it. I hope you learned something. I hope you enjoyed yourself. And I hope you enjoy the rest of the conference.